All right, so here we are. We're talking about source transformation now, which I said is very closely related to what I was doing in the previous slide, where I showed that we can basically take our Thevenin equivalent circuit and replace it with our Norton equivalent circuit and convert between the two simply using Ohm's law. Okay, well, we can use what's called, basically what we were doing here is source transformation. We just didn't call it that yet. This is for the context of Thevenin and Norton. And source transformation is the general context for solving DC circuits. We can use this property that if I have a voltage source in series with a resistor, okay, let's call this V. Let's just call it V source and R source. I can replace that with an equivalent current source in parallel with a resistor in general. Okay, this doesn't need to be in the context of a Thevenin and Norton circuit or a Thevenin and Norton equivalence. Rather, these are just equivalent circuits. This is I source, and I'll call this one R source as well. We know that these two resistances are equal. We determined that previously in Thevenin and Norton. But all I'm saying here is if I have a circuit that looks like this, I can replace it with a circuit that looks like this by using Ohm's law. Either in one case where I'm interested in finding the current, I would say I equals V over R, or let me just write it out as I source is equal to Vs over Rs. If I wanted to go from the Thevenin this is not a Thevenin and Norton, but if I just wanted to go from the voltage source circuit over to the current source circuit, I would use I is equal to V over R. If I wanted to go the other way, I would use V is equal to I times R, because these are my givens here, right? Here I'm given I source and R source, so I can find V source. Here I'm given V source and R source, right? So I can find I source, okay? So this is all that source transformation is. It basically just tells me that if I have a voltage source in series with a resistor, there is an equivalent current source in parallel with a resistor, and vice versa, that I can very easily swap between in order to solve a circuit or make solving a circuit easier on myself. It may not be obvious how this can help us. Why would I ever want to do this? Well, let me show you. In a quick example, let's say I have a current source here with a resistor. Oh, sorry, let me put my resistor in parallel. And then let's say I have another resistor here and a resistor here. And let's say I was interested in determining this node voltage here. Let's call it Vx. I'll give some values. Let's say 1K, 2K, 5K, and then I'll put 10 milliamps right here. Okay, and I want to find Vx in this circuit. Well, this wouldn't be super trivial with previous methods. We'd have to combine these two resistors in series. Then we'd have to use a current divider. And then once we get our current divider, then we would have to come back and pull them out of series to determine Vx. Well, with source transformation, we can just take this piece of the circuit, right, my current source in parallel with my resistor, and I can replace it with an equivalent voltage source in series with a resistor. And then the rest of the circuitry can just get connected to my equivalent, right? And now solving for Vx is trivial, okay? So in this circuit, I have 10 milliamps in shunt or in parallel with 5K. So my V in this case would be equal to I, which is 10 milliamps multiplied by 5K. And that's gonna give me, 50 volts, okay? And then I have 2K here, 1K here, and 5K here. And I want to find Vx. Well, these two guys are just in series, so I can very easily treat this as a voltage divider where Vx is going to be 50 volts times 2K divided by 6K. And that's basically just 50 divided by 3. And Vx is 16.67 volts. All right? So that is how we can use source transformation to our advantage. If we are looking at a circuit that looks like it would be easier to solve with a voltage source in series rather than a current source in parallel, or vice versa, we can just take this piece of the circuit and replace it with this piece of the circuit and keep the rest the exact same, right? I have my 1K and my 2K and my VX here. I have the exact same thing here. And all I did was I took this portion of the circuit, right, and I replaced it with this portion. Okay? That's source transformation. I'll ask you to use it probably on a homework. You may not use it on the exam. I may or may not ask you to use it. You definitely can notice that this is the exact same thing that we were doing with Thevenin and Norton, is basically just saying that these two circuits are equivalent to one another. Sorry. But that's source transformation. This is an example on source transformation. And with that, we're pretty much done with this module. And what I'm going to do in probably the remaining few videos is I'm just going to solve some more example problems using some of these methods, because I know that these methods, there's a lot here. There's a lot of different ways to solve circuits, a lot of different types of circuits. And I really just want to make sure that I solve as many examples as possible so that you guys are confident when you see a circuit that you know how to approach it and how to carry out the solution. Okay, so I'm going to end the video here and probably solve a few more example problems.